to the fundamental theorem of calculus. So we learned part one, which is the derivative aspect, but now we're going to learn part two, which is about evaluating definite integrals. So if f is a continuous function on AB and g is an antiderivative, and it's key here, this idea of g being an antiderivative of f, that we know what that means, then what we have here is that the integral, and I should have put dx, I apologize, definitely you always have to write dx what you're integrating with respect to. G is an antiderivative of f, then the integral from a to b of f of x dx is equal to that antiderivative evaluated at b minus the antiderivative at a. Now we need to understand what it means when we say g is an antiderivative of f. So that means basically that g, taking the derivative, is equal to f. That's all that means when we say g is an antiderivative of f. Okay? It's any function whose derivative is f. Right? That's an antiderivative. And now let's keep this theorem in mind for when I do a particular case. Let's say I'd go from 0 to pi over 2 of, let's say, and it doesn't matter, right, cosine t dt, doesn't matter the thing here. Now all I need to find is an antiderivative for cosine of t. So what function, when I differentiate, do I get positive cosine t? And that's the antiderivative for cosine of t. And you should see that if I take negative sine t, right, what's the derivative of this? It's negative sine t, right, d dt. If I take the derivative, right, well, the negative comes out. Negative, the derivative of, oh, wait, is it even negative? Nope, it's just sine t. And the derivative of sine t, you guys should see, is cosine t. And I should forget about this negative because I thought it'd be a negative. For the split second, I made a mistake. But we should remember that the derivative, right, doesn't matter, derivative with respect to x or theta or t, the derivative of sine x is cosine x, right? And the derivative of cosine x is negative sine x. So then that means that an antiderivative of cosine, right? What function, when I take the derivative of, do I get cosine? Well, if I take a derivative of sine x, right? If I say g, or if I say f of x is the derivative, right, of sine x. If I do the derivative, right, the derivative, I put the little prime there, that equals cosine x. So the derivative of sine x is cosine x, means that sine x is an antiderivative of cosine x. And you can take your time figuring out, basically, that if you want to find an antiderivative of cosine x, you could write it like this, right, as what's called an indefinite integral. That's going to be just sine x, right, plus c. But the c doesn't matter in our case, in this here. So again, as long as it is that if I find a function that when I differentiate, I get back this inside cosine t, then I'm good. And I found one, sine. So that means that this is sine of the b value, which is pi over 2, minus sine of the lower bound, which is 0. And I could write this in an extra step. I sometimes and often will. I forget about writing the integral as that squiggly, and I put it on its bounds, and then I deliberately say the antiderivative. I say sine of t is my antiderivative, and then I plug in, the top bound, sine of pi over 2 minus sine of 0, the lower bound. Sine of pi over 2 is 1, minus sine of 0 is 0. And I get 1 for my answer, and I'm done here. Let's do another example. So I just did this one here. But now let's do this one. So again, right, all you want to do is find an antiderivative for 3x squared. And your rules for finding an antiderivative, right, are going to be the 3 is a constant times, what's an antiderivative for x squared? Add 1 to the exponent and then divide by that same value. And x cubed is an antiderivative for 3x squared. Why? If I differentiate x cubed, I get 3x squared. So x cubed is an antiderivative. So I change the symbol to just the bar. I put 1 to 2, and then I put that antiderivative in, x cubed. And then I'll evaluate. So it'll be 2 cubed, because I plug in the upper bound, minus the lower bound, 1 cubed. 2 cubed is 8, minus 1 is 7. And the answer for this one would be 7.